Hey guys, it's Mrs. Bryant. Welcome back to another flip video. Today we are going to start arithmetic sequences. So press pause and get out your notes, and when you're ready you can press play and we'll get started. It says drag the number sequence to match its pictorial representation. So right here you have 1, 5, then 9. So I'm going to go and I'm going to draw a line, or you can drag the pattern to where it goes. And I'm not going to drag, that way we know we can just start. So 3, 6, 9, 12, 9, 6, 3. So that goes right there. 3, 2.5, 2, 1.5. So that one goes there. Next would be 3, 6, 9, 12. So there we go. This should be a review for y'all of making sequences and being able to tell what they're changing by. So where are your next two terms correct? So here we go. We are going to do the next two terms: 1, 5, 9, 13, 17, 21. So if we do our process, it would be plus 4 to the prior term. This second example, 3, 2.5, 2, 1.5, we should have 1 and then 1/2. And so you are subtracting 0.5. So minus 0.5. 12, 9, 6, 3, negative 3. We're going to be subtracting 3. 3, 6, 9, 12, 15, 18, and we're going to be adding 3. So these are all examples of arithmetic sequences. That means you have added or subtracted a term to a previous term. So which of these represent an arithmetic sequence? Well, how did I get from 2 to 4? That'd be plus 2. So 4 plus 2 would be 6, and that is an 8. So this is not an arithmetic. 23 to 19 would be minus 4. 19 to 15 would be minus 4, minus 4, minus 4. So that is arithmetic. Plus 60, plus 60, plus 60, plus 60. So that is arithmetic. 0 to 3 would be plus 3. 3 plus 3 got you to 6, so this would not be arithmetic. 7 to negative 4 would be negative 11. Negative 11, negative 11, negative 11. So that would be arithmetic. Okay, so in arithmetic sequences, each new term is found by adding a number to the previous term. And when I say adding, you can be adding a positive number or you can be adding a negative number. So when we were finding how we got to the next term, we were finding the common difference. And a common difference is the difference between any two consecutive terms of the sequence. And it must be constant. Here's the thing, it has to be constant. So the term values of a sequence are always numbered 1, first, second, third, and so forth until you get to the nth term, which refers to any term. And this should look familiar from years past in 6th and 7th grade. So you can translate the terms of that sequence into a table format. And because you have been doing tables since kindergarten, this should be very, very familiar to you. So always make sure you're putting your sequences into a table so it looks like something that you recognize. And it wants to know this format is a function, and how do you know? Well, x's don't repeat. Remember, we talked about this a couple of weeks ago. Here's another function table that you know. Remember things like independent and dependent, input and output, change in y, and change in x. So what kind of function is this? And you can notice that there is a constant difference. So what is the equation for this function? Well, if you graph it, that's where your points are going to be. And because, how do I get from 1 to 3? It's times 3. You know that your change or your common difference is going to be your coefficient. This came from last week. And then minus 4 to get you to your 3. So what's the difference between a sequence and a linear function that represent it? Nothing. Because you can come up with the equation with just the sequence. So arithmetic sequences, adding the same number to each term to get the next term, are very much like linear functions. When the change of x equals 1, the change in y is a constant. So which of these are linear functions? Remember, constant rate of change. So that would be plus 2, plus 4, plus 8, plus 16. This would be plus 1, plus 1, plus 1, plus 1. This is not a function. I'm sorry, not a linear function. It is a function. Because it's not a constant rate of change. 2 divided by 1 is 2, 4 divided by 1 is 4, and so on. These numbers are not the same. This would be 60, 60, 60, 60, and each of these change is 1. So that's how you know that that is a function. 3, 3, 3, 3. So far it looks good. 1, 2, 1, 2. 3 divided by 2 is not the same as 3 divided by 1. So this is not a function. This would be minus 4, minus 4, minus 4, minus 4. And because these are all ones, we know that this is a function because it has a constant rate of change. This would be plus 3, plus 3, plus 3, plus 3, and these are plus ones. So it is a function, or linear function, because it has a constant rate of change. So which of these represents an arithmetic sequence? So 1, 2, 3, 4, 5 is your term number. 1, 2, 3, 4, 5. And so it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now find your difference. That's 2, 4. Because these are ones, we know that this is not a function because there is not a constant rate of change. Because 2 divided by 1 is not the same thing as 4 divided by 1. Minus 4, minus 4, minus 4, minus 4. And because these differences are 1, this is a function. This is a function we've already proven. This is a function because we've already proven it, and so is that. So, one more level of knowledge for arithmetic sequences is the language. It says, move the symbols under the parts of the sequence you think it represents. And I'm not going to do it right now, but here would be the answers. Previous terms, first terms, nth term, and common difference. So on your paper, you can draw an arrow to where it matters. Nth term is going to be right here. The first term is going to be right here. Previous term is the term before the end, so that would be the previous term. And here are all the different ways that you can name these terms or that language. So finding the next term, we are going to learn about two formulas, the recursion formula and the function formula. The recursion formula is finding the value of a term, Tn, that could be any term. Notice n is the based on the term before it, which is Tn minus 1. So the term you're looking for and the previous term. In this example, Tn equals Tn minus 1 plus 3 because we're adding 3 to each term. So let's do an example. So, fill in the blank. To get each new term, I add blank to the term before it. So I'm subtracting 5 or adding a negative 5. What is the recursion formula for the sequence? Tn equals Tn minus 1 plus a negative 5. So what are the next terms? What are the 3 terms of the sequence? 25, 20, 15, 10. It's really easy. When it gets to the geometric is when we're going to get confused. So for finding any term, so let's go back. This is finding the next term. Recursion means next. You're going to need to know this because now we're going to talk about finding any term. And to do that, you're going to use the function formula, which is right here. Remember, Tn is the term we're looking for. Tn would be the first term. D stands for difference. N is the term we're looking for, minus 1, so you're looking for your previous, that should be a minus 1, not a 4. And that's your previous term. All right, so in this example, Tn, that's what we're looking for, equals 12, first term, plus 3, because that's the difference, n minus 1, so n minus 1 could be any term we're looking for. So now it's our turn. I start with blank and change by adding. I started with 40 and changed by adding a negative 5. What is the explicit or function formula for the sequence? Well, 40 plus a negative 5, n minus 1. So what is the 32nd term? Well, let's find out. Okay, so we want to figure out what the 32nd term is. So 40 plus, we can do it this way. 40 minus 5, and n minus 1 means the previous term of 32, so we got times 31. So what that looks like is 40 minus 155, and so your answer is going to be negative 115. The 32nd term is negative 115. We will do this foldable when we get in. Actually, make sure this foldable is cut out and glued into your ISN, and this is what goes underneath those tabs. We will do those in class. So we will review these topics in class, these questions in class tomorrow. So just make sure you have all your notes done. If you don't do the foldable, that's fine. We can do that in class tomorrow as well. And make sure you do the survey, and I will see you in class tomorrow. Have a good night.